Hello everyone, welcome to Engineering Math Tutorial 1, first ODE. So we first see the sections A, types of ODE. So for each of the following ODE, determine its order, determine whether it's linear or non-linear. But before we look into the answers of these differentiation equations, let me remind you what we have learned in the class. So the order of ODE for a given differentiation equation is referred to the highest derivative in that differentiation equations. So for example, questions A, we have two derivatives. The first derivative is the order of 2 and the second derivative is order of 1. So the highest order is order of 2. So this differentiation equation is called second order. Now, to determine whether the differentiation equation is linear or non-linear, then every terms in the differentiation equations must fulfill a certain condition. Now, assume that we have a general forms of the differentiation equations a y2 primes plus by primes plus cy equal to function of x. So a linear differentiation equations must fulfill these conditions. So the condition 1, so the coefficient value of a, b, and c are constant. Or it can be a function of x, but can be function of y. So the second conditions for the linear differentiation equations is that the derivative and the unknown function y must have the power exactly 1. Meaning that in these differentiation equations, the y2 prime must be power of 1 and y prime must be power of 1 and y unknown function must also power of 1. If you see one terms of differentiation, one terms of derivative in these differentiation equations, for example, unknown functions is the order of 2, then this differentiation equations is non-linear. Now we see conditions 2, no trigonometry functions of y and its derivative. Now for example, if you see sine y or cosine y in these differentiation equations, then the ODE is non-linear. Now we see conditions 4, no product between y and the derivative. For example, you see the terms in the ODE is y times dy dx or y times d square y dx square, and this differentiation equation is non-linear. Now conditions number 5, no inverse of y. For example, if you see one term which is 1 over y in the differentiation equation, then it is a non-linear. Now with these informations and knowledge, we can determine the answer for the following questions. So questions A refer to these questions. So the highest order of this differentiation equation is 2, so it is second order. Now we see the derivative and unknown function has a power of 1, so this is a linear differentiation equations. Now we see questions B. The highest order in this differentiation equations is 2, so it's a second order. Now, is this linear or non-linear? We see we have a product of y squared times d squared y dt squared. So the power, so this is a product between the unknown functions and the derivative, so it is non-linear. Now we see question C. The highest order derivative is 4, so this is fourth order. We see each of these derivative is a functions is the power of 1 for third, second, and first, and also the unknown function is power of 1, so this is linear ODE. Now we see questions D. So the highest order is first order, and it is linear or non-linear. Now we see we have unknown functions with power of 2, so this is non-linear. Now we see questions E. The highest order is 2, so this is second order. And we have a trigonometries of unknown function y, so this is non-linear. Now we see questions F. The highest order is 3, so this is third order. And we see here the third order is a power of 1, and the derivative, the first derivative also is power of 1, and unknown function also is power of 1. So this is linear ODE.